button on this computer. Okay, so it's the final week. We are going to have an exam next week, so just pay attention to what you learn and what you know, what you don't know, and then let me know whenever you guys need help. Okay, I think this homework is much easier, could be straightforward. The homework is here is because I want you to try a little bit about the CDF method. Okay. Using CDF as a pivot, so let's go through that. And then using CDF as a pivot is actually very straightforward. Only thing you need to do is actually only derive CDFs. Okay, but of course, what CDF you need to derive, you need to pay attention to that. Okay, so if I have x1 to xn, follow a PDF function, which is, it looks like a scale family to me, actually. Okay, so then you do have a range of x depending on theta. So in that case, you would have in that idea about what kind of statistics you are going to use, right? So again, because of the range of x depending on theta, and then it's the upper bound. So I think basically I will use the statistic I'm going to use is what? Xn. Okay, then I'm going to deriving Xn's CDF. Xn CDF. And then I'm going to using the Xn CDF, use as a pivot to derive upper bound and lower bound. And again, you might think that the path for you is what? The path for us is what? I do have CDF. Basically, it's a function of theta right here. If that's a decreasing function of theta, then by that CDF method, we are going to have in that, let me see, CDF, okay, alpha 1, and then 1 minus alpha 2. Of course, alpha 1 plus alpha 2 is alpha, okay? The inside the range right here is 1 over alpha, okay? So that means that gives a pivot 1 minus alpha equals to probability of pivot right here is the CDF of that statistics. Okay, right here. It's between alpha 1 quantile to quantile if we do have pivotal quantity inside in the central part. Okay, then normally we are looking for decreasing function, but I cannot rule out it might be increasing function anywhere. Anyway, if it's really a decreasing function, you will know that we are trying to find lower bound to upper bound for theta. And then again, it's the CDF method look complicated, but actually it's not. Just draw a graph, and you will see I'm going to using upper bound of quantile to find the lower bound of the theta, lower bound of the theta, because this is upper bound of the quantile, trying to find lower bound of the theta. And then using lower bound of CDF to find upper bound of theta in 1 minus alpha comes interval. Okay, so drawing a graph, you will see that what happens. But of course, you need to make a judgment call it's whether or not it's a decreasing function of theta. Okay, and you look at it. Okay, I'm guessing using Xn as a statistics T. I'm going to deriving x and CDF. Okay, so deriving x and CDF, everything just the same thing, going back to our very beginning of the class, right? Again, you can use a formula to deriving PDF of xn, using the PDF xn to deriving the CD of xn. Okay, but I always do this because it would be really easier for me to see the whole picture, not necessarily using the wrong formula and get wrong results. Okay, so that means, okay, I'm not going to write everything again. You know where I'm going, right? You know why I'm trying to write this. Because xn, largest one smaller than something, everyone smaller than that thing. So the power n. And then that means I'm going to deriving original x1 to xn CDF. Okay, I'm going to skip that. I think guys can handle that. For example, right here, it's nothing but what? Remember, this is CDF. Inside guy is a PDF. But don't forget about your range of x. Okay, it's from 0 to x right here. Okay, good. So that means eventually, let me give you an answer directly. Is xn divided by theta, then with power a. Not surprising to see that if you have this PDF right here. Okay, now how to derive as well. Okay, then with power n, so you have power n right here, an right here. Okay, whenever you have in that CDF method, then look at this right here. Increasing function or decreasing function of theta. Easy, right? Theta in the denominator. When theta getting bigger, the whole function what? Getting smaller. So not surprising to see that it's a decreasing function of theta. Okay, of course a got to be positive, I think. Bigger than 1 as well. Yes, like the question indicated. If a is smaller than 1, then it's another story. Okay, but right now pay attention to your range of a. So question says a is bigger or equal to 1. So it's actually decreased function of theta. If you make that judgment call correctly, then you do know how would you find your lower bound and upper bound, right? Again, it's what? Again, it's we are trying to using upper bound of the quantile of the CDF to find lower bound of the theta right here, which means that it's this guy right here, CDF right here, is 1 minus alpha 2, right? Okay, so which means that this guy got to equals to f equals theta equals to L right here. Making sense? This is a function of theta, right? You plug in theta as a lower bound. In terms of function value, it got to equal to what? 1 minus alpha 2 right here. So writing this shouldn't be hard to see. As well as if you really want to find lower bound right here, we can later on to write it. If you want to write right here, so alpha 1 right here equals to what? Alpha 1 function value right here to here, which means that it's you got to make the theta equals to upper bound. Then in terms of function value equals to alpha 1 right here. Making sense? If you know that, and if you know that, and you have this function value right here, then everything becomes clear, right? For example, using 1 right here, using the first star right here, okay? Nothing but plug in x divided by L lower bound right here, then with an, right? That's what this means, right? You plug in theta equals lower bound. And then you have function value. You have function value like here. You see that? Right? Nothing but plugging theta by lower bound. There's a function value then equals to 1 minus alpha 2. So if you do see that, that means using that you can solving for lower bound right here. Okay? You could what? You could take log 1 minus alpha 2 on both ends, right? Or you have to type log. You can actually just saying it. I have 1 minus alpha 2 in the left hand side, taking 1 over an right here. Okay? Equals to x divided by Lx lower bound right here. And then, okay, so this guy is not x, this guy is actual xn. This x right here is xn, right? That's a CDF of the xn's. Okay, good. And then doing that implies what? Implies you could write lower bound equals to xn. You flip, right? You flip, then move to the left hand side, and then become xn times alpha 2 minus, because you flip. Okay, again, you flip, then this guy become negative, and then because flipping, you have xn in the denominator, then you move to the left hand side, become this. Okay, so you find your lower bound. And similarly, if you're working on the upper bound, right here, okay, then you will what? A1 equals, again, you plug in theta as upper bound into where the CDF is. So that means I plug in, again, it's upper bound. Then xn again as well, CDF of xn, then with an, right here. Okay, then using that, now how to see, I can do this 1 over an, the same thing as right here, and then xn divided by ux1. Okay, then doing the same thing, flipping, then times to the left hand side, become u upper bound equals to xn times alpha 1 minus 1 an it. Okay, so by doing so, you find our upper bound and the lower bound. Okay, let me just pull up, sorry about that, for you to see right here. Good. So I think you finished the first question, you finish A, trying to using CDF to find lower bound and upper bound of the theta's 91% constant interval. Okay, literally you want to write 1 minus alpha, right? Use the probability of lower bound, then theta, then upper bound, it's okay, and then this is A. Of course, in the class, I tend to do so, and especially our question allow you to do so is what? You can actually trying to do your algebra directly, saying alpha 1 is original pivotal quantity. Okay, right here, right? And then you plug in your CDF in the middle part, which means that it's n theta, then an, right? And theta an, I think. Yep, and then smaller than 1 minus alpha 2. Let me double check. Yep, I think so. So you may wonder, why not just working on my algebra directly? I don't have to using complicated things right here. Okay, good. I don't using this is general for each of the solutions of lower bound. Right here, you could see is what? You just see directly is what? I can taking power 1 over an both sides. Right, you see that? I could do so as well, right? Because a is bigger than 1, and then everything is positive. So doing the power doesn't change the sign, but flipping changes signs. What I mean that is what? If you reflip theta xn, if you look at flipping, you should know that it's bigger one become smaller one, right? So actually, whole thing right here should be, it's not minus, right? Yeah, it's not minus. Oh, it's minus. It's minus. Sorry about that. It's minus. Let me double check on that. I don't have solution here right now. Yeah. Okay. So if I do that, you flip, then become an. Then right here is what? Because you flip, become alpha 1 an, right? Flipping. Yeah, I think so. And then it's actually probability of theta inside guy xn times 1 minus alpha 2, then an alpha 1, then an. Then of course there's x1 right here, x1 an alpha 1 an. It's the thing that's right here, right? You just really minus the inverse. I think so. Did I make any critical errors? Coming back. An minus 1. Oh, yeah. Flipping inside guy. Right. They're the same, I think. Okay. Good. So that means you could also using direct operation of algebra to find your solution of lower bound, upper bound. Right? But you won't get lucky every time doing this. So it's better still writing down as a general approach to find lower bound, upper bound, I think. Okay, of course you can try this guy first. If I do give this in the final exam, and to see if you get lucky. Okay, good. And then the reason I said it, this course homework is really easy. It's you look at B. Look at B right here. That's exactly the form of the CDF, right? It's exactly right here. So they're automatically saying that it's a pivotal quantity, because you could say it's xn and then theta an is a CDF of xn. So then it follows normal 0, 1. You could say so, okay? Or, well, you could basically derive in a whole C term to show that actually is what? You could say yi, it's this guy right here. A nail an. Yeah, it doesn't matter. And then you're deriving y's CDF. And you will see that eventually equals to y. Actually, okay? You could try to say so, which means that it's trying to derive in whether or not. For example, if you write down less, an right here, smaller than y, right? I bet eventually this guy is y, okay? Then it's not hard to derive so. For example, you don't have to say, well, this guy right here using general form. You could using general approach to saying that CDF is 101. Or you could just say right here, it's right, you're taking pivotal, right? Xn divided by theta, then with y, then an, right? And then equals to probability x1 smaller than theta, y1 over an, right? And you do know yn's CDF right here. Now, I'm sorry, xn's CDF right here, right? This is xn CDF, which means that it's you plug in what your right hand side is. So this probability equals to, you plug in, say, this theta, okay? Then you plug in right? This guy is little x, right? Right here. You plug in where x right here, right? That's so-called xn's CDF. And you'll find out is what? Cancel, y 1 over an times an become y. So then you could say that is, well, xn theta an follow 0, 1. Or you could just say is the right hand side right here independent of theta. So that make the quantity right here is a pivotal quantity. Okay, if we want to show so, you could do so. Okay, if we write this directly, I think it's okay because we all know that CDF follow 0.01. It's okay, but if we want to see it, you could follow this kind of directions, trying to show that the CDF of the quantity is independent of theta, so such that the quantity itself is a pivotal quantity. And then everything just go back to this, right? Go back to this. Okay, and then through the operations, you'll find the same length. You will find an identical CDF as AX. That means you'll see the answer is for C is what? It's just identical. Okay, so that means comment on which one would you prefer if they are different. Well, they're identical, so there's no comparison about which one you want to prefer. Okay, to me. Okay, good. So I'm going to using some time because it's only about 12:38. I'm not going to just let you go. Okay, I'm going to talk about something. It would actually happen in a final exam like this right here. So I'm asking you A and B. Well, I might ask you the same thing right here. I'm not necessarily saying whether identical. I'm not going to asking you. Okay, I might as well asking you to see what your argument is, whether or not it's identical or it's different. Okay, so I might having the same thing right here. Don't laughing at, well, it's identical, so it's easy. Get 10 points, of course. Well, if you have some argument right there to let me know what you think, right? So then, of course, I'm going to asking about it since you have lower bound, upper bound. And this is a very large question, is what? What is the length of confidence interval? Right? In this case, is what? In this case, it's the length of confidence interval is you have A1, lower upper bound is xn, a alpha 1 an. You have x1, xn alpha 1 an, so alpha 1 an, right? Minus xn, lower bound is 1 minus alpha 2, 1 minus alpha 2, then an as well. Okay, this is the length of confidence interval. It's very large for me to ask what's expected length of confidence interval length. Okay, and how do you derive it? Just very straightforwardly deriving the whole thing. And then it's actually not hard to derive because this is really nothing but asking you what? It's really nothing but asking you to derive expected value of x and x, isn't it? Then how to do this? You're going back to original x and CDF. Okay, you do CDF right here, as well as what? PDF, right? So PDF, I think it's going to be what? Expected x and, okay, x and range the 0 to theta, I think. Then x f of x and CDF, PDF. Okay, so then x and PDF based on x and CDF, I think eventually it's you taking an, so f of x and then x, you taking an down, I think an down, now an minus 1 happened later. You put an down, you put your x, not xn, x, then theta, then an minus 1, then divided by 1 over theta, as a chain rule. Okay? So use that to deriving your expected value of xn. Okay? So I will help you work on it, and then eventually expected length. Okay? That's number 1, I think I'm going to ask. Number 2, I'm going to ask it. Going back to original question, I said it looked like a scale family to me. Let me go back to the, it looked like scale family to me. Right? If you're going back to the slides, in the scale family, what I said, what's the pivotal quantity, what's the natural pivotal quantity I'm going to choose? Is x bar divided by theta. Okay, so I might well to try this approach to see what happens. Although I don't have solution key, although I don't have solution key right now with me, but I'm going to try a little bit to see how far I can go. If I cannot go too far, then let's forget about it. I'm saying we can working on more details after class. Okay, so first of it, I will show that. So first of it, in the final exam, our past question asking you is, so if I say scale family, so this guy right here, this guy right here, this guy right here should be what? Distribution independent of theta, right? That's what scale family is. Okay, then you're going to see, wait or not, in the final, I'm going to ask you deriving the new PDF using what? Transformation method, right? So nothing but zy x, then dx dy is theta. Okay, inverse function, Jacobian, straightforward. So I do have original x right here, right? And then I'm going to plug in theta y it, and then having my Jacobian. Okay, so what's that? So I think, so a theta, then having that theta y plugin, then theta a minus 1, then dx dy is theta. So that means cancel out, cancel out, cancel out, cancel out is what? A y a minus 1 is exactly independent of theta. So that's true. That's scale family. And then by doing so, the new range of y is from 0 to 1. Okay? So then that give me some hints about what this PDF is going to be. Follow distribution. Like I said frequently, this range is from 0 to 1. Only chance we have, only two choices we have along the way. The domain is from 0 to 1 is what? Either uniform or beta. This guy definitely not uniform, so it got to be beta. Then alpha and beta inside the parameters. If you check it, I think it's 1 and A. Okay, so just Google it, looking at Wikipedia or looking at the Kassenberger's book. I think it's 1 and A. Okay, good. And then I might imagine it. Can I do summation xi? For example, like I said, it's if it actually is a pivot, the xi divided x bar divided by theta is going to become pivot if that guy is actually a scale family. But right here, to me, is I don't know much about beta distribution in some summation xi. But if you remember when we work on meter number 2, use this PDF in meter number 2, right? So by the way, I actually posting the scores on the from meter number 1, I think. Yeah, meter number 1. So by the way, I posting meter number 2 scores back to you guys already, so you can check it on Sakai. Okay, but almost everyone get good scores because average is 95, I think. Okay, amazing. Good. So if you remember meter number 1, maybe, yeah. Well, forget about it. So should be meter number 1. But if I'm wrong, I forget about it. Okay, but point is, you see that before, right? You do have xi or figure yi right here. Y right here. Having this PDF. And then domain is from 0 to 1. So if I write this, you might remember what I'm talking about. If you redo another transformation again, minus log yi. Okay? So if you read it out again, so we can do it really quickly, right? E minus z equals to y, then dy dz it's e minus z, then minus 1, of course, taking absolute value. This guy is gone. Okay, so then you're working on your original PDF, plug in new y's, and then with Jacobian, plug in transformation, Jacobian, plug in transformation, Jacobian. So then plug in e minus z, then become a e minus z a minus 1. Okay, and then times e minus z become what? A e minus a z. What this guy follows then? Nothing but exponential 1 over a. Right? Especially from 0, 1 doing minus log transformation become infinity. Perfect. Exponential 1 over a. It's okay. By doing so, then you will know that where that summation zi follows that, right? Again, it's what? Gamma, then n, then 1 over a. It's okay. Good. And then you might even want to write you might also even write as a z bar follows gamma and then 1 over a n. It's you could do so as well. Okay, so that means if I do so, z bar equals to n summation zi equals to n minus z bar is summation log yi, right? Well, yeah, where is my theta then? Good point. So that means I'm looking for theta to become a pivotal quantity. Otherwise, it's no use. So I think right here is what? Log xi minus log theta, I think, right here, right? Let me get again, so stop a little bit to make sure that I get correct. Y is xi divided by theta. So taking log become log xi minus log theta. So far, so good. So that means right here is what? I do have minus n log. Okay, again, start with a bit. Zi is log of yi. Okay, so that means I can write that summation log xi. Okay, and then then plus log theta minus summation log xi divided by n, then plus log theta. I think so. Okay, so I do have my theta right here. Okay, so that means I can using z bar right here as my pivotal quantity right now. Okay, so then how about this? I think so far so good. I do see where I'm going right now. So if I do that 1 minus alpha comes interval, I'm going to using z bar as a pivotal quantity. That means z bar right here follow what? Follow right here. Okay, so that means I can write quantile to quantile using alpha 1, right? Alpha 1, so n 1 over an, then alpha 1 as a quantile. The inside guy becomes z bar minus n summation log xi, then plus log theta, right? Inside guy is a z bar. And then quantile to quantile, n 1 over an, then 1 minus alpha over 2x. You guys see that? So this is follow gamma n 1 over anx. So I can write quantile to quantile like that way. Or if you don't feel comfortable, so if you say in some way you would imagine z bar, okay, I'm saying it's if I'm using gamma right here, there could be as well. Okay, I think the same, just like divided by n, for example. Okay, just write it here. If we really want to using summation xi, using that, the left hand side become n, then 1 over a, then alpha 1, then right hand side become n 1 over a, alpha 2. I meant to say so using this guy, but then you change it to summation zi become so right here I'm going to jump. Okay, hope you can see that. Summation z, I think, become like summation log xi, then minus n log theta. I think it's plus n times log theta. That's doable as well. Although by writing, they look different quantile, right? Okay. Okay. Either way, I think eventually it's what? You still need to put theta in the middle, but right now it's you'll find out eventually what? Eventually become let me work on which one. I'm going to working on this guy right here. Okay, so that means taking a bunch of these things, and I'm going to write here. It's much easier. Okay, because I like log and theta in the middle. So that means I would write it what? N summation log xi move to left hand side, then plus gamma n 1 over a n alpha 1, then smaller than log theta, bigger than n 1 over a n 1 minus alpha 2, then plus as well. Okay, writing too quick. So summation log xi divided by n, then plus gamma n 1 over a n 1 minus alpha 2 would be. Okay, I gotta check. Hopefully I didn't make any errors. What does something a dot 1? Okay, good. So right here, I think so far so good, unless you find any hole on this. Hopefully I don't make any like computation errors. The good point is eventually what? How to put theta in the middle? Really nothing but exponential both, right? Okay. So that means using this approach, you got totally different 1 minus alpha comes interval compared to the CDF methods. Right here. Oh no, it's not here there. Sorry about that. Here. Right? And the one is using xn, the other one's using different statistics. Okay, good. So although right here it's not straightforward like using xi as some kind of some statistics, you do need to take in the log minus log xi's to see that would happen. But line by line, it looks reasonable. And then eventually, again, I might, although I think this is difficult, I might ask you it, could you deriving the lower bound minus upper bound minus lower bound, could you deriving expected length of the constant interval? Okay. I don't know how difficult that is. Okay. But it looks like what? It looks like eventually it's, you do need to deriving expected value of summation xi divided by n. Then, of course, this guy right here, I can just say so. Gamma n 1 over a n alpha 1 minus gamma a of n then 1 minus alpha 2x, right? This guy times this guy going back to this guy, right? Okay, and then eventually you need to working out of this. Okay, I don't know how difficult. That might not be difficult at all, actually, because you do know about the distribution of this guy right here, of going to taking minus though to get that summation yi. Okay, so I don't know how difficult that is. It might just as easy as taking care of exponential. You can get that expected value of that variable. Okay, so it might happen in the final, but one thing I want to point out is before your final like this, I will guarantee one thing is I'm going to derive in this first. If it doesn't go anywhere, then I'm not going to give you that. Okay. Or if I think that's too difficult, taking too much time for you to deriving the answers in the final exam, I might just will give up. Okay, good. And then, but I might give you some open-ended question. For example, which one would you prefer? This guy or this guy? This guy or this guy? Okay. And then it's actually, in this case, become open-ended questions. So let's really know straightforward for me to look at which one would you prefer. Sometimes because theta, domain with theta is bigger than 0, right? I think, let me go back to, right, theta is bigger than 0. Okay, and then with theta bigger than 0, you would prefer something, your lower bound, upper bound, your interval is positive on both ends. To me, right here, these two intervals, both ends are positive. So I cannot just looking at that thing to tell you which one would I prefer. Okay, because both interval give you positive lower bound, upper bound is both ends as a positive. And then, yeah, intuitively, I cannot tell which one have a shorter length. Okay, but one thing I might actually asking you is, yeah, one thing I truly would be possible asking you is, if this guy is too much to derive, so, okay, hopefully you can follow me to what I'm trying to say, okay? Because your final is going to cover so-called asymptotic comes interval, okay? Of course, both guys are exact 91 minus alpha comes interval. That's one thing that you need to want to know. That's one thing you need to ask yourself. These two intervals are exact intervals, are asymptotic intervals, or approximate intervals. Which one? These two guys are exact comes interval because they're all deriving from exact distribution. Okay, that's the number one thing to know there. The second thing is, okay, if this interval is so complicated, if you follow me on this, right here, okay, or actually this might be easier to look at. This might be easier to look at from the very beginning. Okay, right here. I think you guys are so creative in meter number. I think you guys are so creative in meter number 2. The reason I say so is in the final questions, while I'm looking for exact testing, some of you give me approximate testing, which means you guys do know how to using central limit theory to get that asymptotic test. Okay, I don't even teach that yet. You guys know how to use it. The same thing right here. Okay, I know this guy is gamma in some sense, right? I also find my friends right here, summation I from 1 to n. Okay, the whole thing right here is nothing but y bar, right? If I do know that's y bar, then I can use in central limit theory, okay, to derive the asymptotic comes interval for theta, or approximate comes interval for theta. Okay, then in that case, I think end-to-end, quantile to quantile would be much easier to handle. And then this most likely is Z quantile. And then the expected length of the asymptotic comes intervals would be much easier to derive. Then at that time, I might be using that to compare to A, because A's expected length is much easier to derive to me. Okay, so I'm not going to do that right now because I'm a little bit, I maybe do that after the class to see how easy that is. Okay, if that's really easy, I could definitely pass that to you in a solution key for you to see what happens if I actually using asymptotic comes interval to derive these questions. Okay, good. So I think I can stop here. That's all I want to say today. So any questions? Yes, Tianhao, questions?
Professor, can you hear me?
Oh yes, I can hear you.
Okay. So it's about the other problems of this assignment.
Other problems. Which problems?
Yeah, first is the fourth one, which is 9.3 of Kostenberger.
Hold on a little bit. I need to pull out solution key to make sure that I follow what you're talking about.
Okay.
So you are saying that let me see. Homework number 9.
Oh, the third one.
You are talking about the homework number 9, number 1 or number 4?
Yeah, number 3, Kostenberger.
Number 3?
Yes.
Kostenberger 9.3?
Yes.
Okay, hold on. Let me pull out solution key so it's easier for me to follow what you're talking about. So okay. Hold on. 9.3. 9.3. Go to yes. Okay, so it talks about MLEs, right?
Yes.
And then so A or B. B is plugged in, so B should be straightforward. Yeah. What about A? What's the problem with A?
Yes. Actually, I think this question is very like your problem 5. The distribution are very similar, and the problem is in the first is in the solutions.
Yes. Oh, you are saying it's the identical questions?
What do you mean?
So are you saying they're identical questions?
I think they're very similar, but the question.
Okay.
Yeah. So the in the solutions, there's a line saying the MLE of beta is the maximum of x's.
Yes.
And
Yeah.
since beta is a scale parameter and xn over beta is a pivot.
A pivot. Yeah. Then.
So I mean, where is this from?
So
I remember your lectures where the scale parameters are included. That there's first the domain of x is not dependent on beta on parameters, and then we can see that x bar is a pivot. X bar over beta is a pivot.
Right.
Yeah, that's in your lecture.
I think I have to told you my thinking is xi divided by beta is definitely pivot. And then, but the question would be is, I think you're asking is, does really everything in terms of mixed model statistic divided by beta is a pivot? I don't think so.
I think its logic is the MLE over the scale parameter is a pivot.
No, not necessary.
Okay.
It's because it's I mean, it's really so. If it's really general, you can find something. Your mixed model statistic divided by beta is not pivot. So then, but this particular case is because xn itself is a scale family.
Yes.
So then, I really don't think in general it would be true. But in general, xi divided by beta is a pivot. You know what I'm saying? So if your x1 xn is scale family, your xi divided by beta is definitely pivot. That's the definition of scale family yet.
Okay, that makes sense.
Right. So it's happened to be xn itself right here, also scale family. Mixed model statistic itself is scale family.
Yes.
So that's what I mean. What I mean is, I think you can find something x1. For example, if your x1 xn is a normality, 0 theta square. Okay. If you have in there xi divided by sigma, it's scale family for sure, right? It's pivot. It's a pivot. You could derive in the xn's PDF, mixed model statistic PDF. I don't think. Maybe that's still true. The reason I say still true is all the statistics itself is just.
I think this scale family is not what we think it is. What we introduced in lectures, the scale families domains are not dependent on the parameters.
Oh, whenever you divide by theta. right here, if you divide it by theta, the domain is independent of theta. Beta right here. I'm sorry.
I mean, like in our lectures where we used X bar,
Yes.
the what matters that the domain is like from negative infinity to positive infinity, or like 0 to positive infinity, which is independent of the scale parameter.
Yes.
But we can, and then we can use the X bar as the pivot.
Yeah, you could.
But here, so, this is not the scale family we define like that, because this actually.
No.
Yeah.
No, it's well, but the point is, again, it's like I said, even though I said X bar divided by theta is a pivot, but it's not necessarily only pivot you can use.
Yeah, I understand. Why this is a pivot, but I just don't quite agree with the term scale family here.
Yeah, then I don't like. I think it's too dangerous for him to write here.
Yeah.
So just claim that max model test divided by beta is a pivot.
Okay.
Then, I don't know if it's a weird distribution. You could try x1, xn. It's
I think they are. Normal. They all are. Yeah, they all are.
They all are. Okay. Yeah. Maybe just exponential. No, it's not possible. Yeah. I think it's a little point. I mean, it's not really critical in terms of just how you define that.
Okay.
Right. As long as your quantity itself is a pivotal quantity, I don't think it will be matter whether or not.
Okay.
You know what I mean? As long as you can show that the quantity you have is independent of theta or beta right here. It doesn't matter that coming from scale family or any definition of scale family is.
Yes, I understand.
Okay.
Yes.
Got it? Okay.
Yeah. And another question, several other questions. Yeah. The second one is for a student